This is what we deal with mostly in biochemistry here, these yellow top samples. We get about 1,600 of these a day, and we do about an average of 15 tests on each sample. The first thing that happens is all of our samples go onto this pre-analytics module here, which is called the MPA. What it does is it scans a barcode on each sample, makes sure that it's registered in our computer system. It checks to see what tests are required against it, and then it goes about processing that sample and getting it ready for analysis. The first thing it does is spins the sample in a centrifuge, which separates the blood component off from the serum component. We're more interested in the liquid portion of the blood, the serum, and then aliquots that off for analysis, and that gets sent on to our analyzers. The original sample is then capped and it gets archived, and then we can retrieve it if we need to do anything more with it at a later stage. The first thing we have here is what's called an ISE module, which stands for Ion Sensitive Electrode. So these can do about 2,000 tests an hour. It's very quick, it takes about 3 seconds per sample, and it's very accurate. So this is our 701 module. This is our primary chemistry analyzer. There's about 400 cuvettes in it, individual cuvettes, so it can run about 400 tests at the same time. We use this for measuring things like total protein and glucose, stuff you find in the serum of the body in quite high quantities normally. And because you're looking for a colour change, there needs to be enough of it there to cause that colour change to happen. So this is what we call our 502 module, which is another spectrophotometer. Instead of measuring a colour change, you add an antibody specific to whatever you're looking for to the cuvette and the sample material. You mix it together, and as the antibody binds to whatever you're looking for, it turns the solution cloudy as it comes out of solution, and then you measure the amount of light absorbed. So it's a little bit different, and it's used mainly for looking for different proteins. For example, C-reactive protein, which is an inflammatory marker that's very good for judging level of infection, and doctors like to use it so they can see if someone's recovering from an infection. This is what we call an immunoassay analyzer. With this here, we can raise an antibody to whatever we're looking for, say for example, thyroid stimulating hormone, and it basically allows us to do a lot more tests. Diabetic patients have to closely monitor their blood glucose levels. One of the ways in which we can determine if they're maintaining a blood glucose control over a longer period of time is called an HbA1c. So instead of a blood glucose level, which gives you a rough idea of how good diabetic control has been over the past 24 hours, an HbA1c gives you a very good idea of how good blood glucose control has been over the past 90 days. The way it's analysed is on this machine here, which uses HPLC, or high performance liquid chromatography. What happens is the blood cells are sampled, they're then broken apart or hemolyzed, they're passed through an ion exchange column where all the hemoglobin binds to the beads in the column. We then pass through one of these eluting reagents, and we change the ratio of the two reagents, and as that changes, it elutes off the different HbA or hemoglobin compounds. And depending on the time that they are eluted off, we can determine what the specific component is, and then we get a nice little graph, and we have a look at it. By measuring the area of the peaks, we can determine how much HbA1c there is in the sample. So this is the manual section of biochemistry, where we primarily deal with protein electrophoresis. It's used for looking for signs of a leukemia-like condition called multiple myeloma. We use this machine here, which is a capillary electrophoresis machine. It passes a small amount of serum from blood through a very narrow capillary and applies an electric charge to it. And because all the stuff in your blood is meant to be sort of different size, shapes and charges, it can separate it out based on size and charge. And we get a couple of lovely graphs. What we're really looking for is any abnormalities right at the very end of that graph. So in one example that I've shown you, you have a normal pattern where you have just a nice sort of hump at the end of it. And in the other one, I've shown you an abnormal pattern where you have a massive spike, which is that monoclonal protein that we're looking for, and that'll be dealt with by our hematologists. So when you take a blood sample and send it up to the laboratory, obviously it takes a little bit of time for the results to come back. We have a turnaround time of 90 minutes for our urgent samples, 4 hours for samples taken from wards, and 24 hours for samples taken from the GP.